Hi, we are Group 8 for Spring 2024 capstone at Iowa State University's Department of Industrial and Manufacturing Systems Engineering. I'm Emily and I work with Abbey, Sarah, and Emma on our project with Nestlé Purina. Our project focuses on optimizing and modeling the product conveyance system for Nestlé Purina's mini treats department. Nestlé Purina's mini treats department in Clinton, Iowa produces dog treats including Bacon strips and Prime Bits. This project focuses on the frequent operational stoppages experienced in the product conveyance system between the processing and packaging departments, specifically for North Line 33 and South Line 34 as it generates excess cost and waste. The objective of this project was to reduce operational stoppages in the product conveyance area by 10% across the mini treats department.
Before providing Nestlé Purina with a solution, the team had to first understand the product conveyance system. The Pareto charts were made using historical data. In the top left corner, there is an all feed instances chart, which compares the number of stoppage instances for the product conveyance system for all product types, including Bacon strips and Prime Bits. It was confirmed that out of feed was the primary problem type, accounting for 92.3% of all stoppages. A similar trend appeared in the all feed units chart, shown in the middle of the top line of charts. This chart compares potential units lost during the stoppages in the product conveyance system. Out of feed was the primary problem type, accounting for 89.7% of all stoppages. Next, the team compared treats lost per second per run type, collected during the current state analysis work sampling study, with Prime Bits on February 14, 2024, displayed in the top right corner. These were two run types. The start-stop run type meant that the product had gaps in flow, and the uninterrupted run type meant that there is continuous product flow. The start-stop run type lost about 3 treats per second, and the uninterrupted run type lost about 1.8 treats per second. It was concluded that stoppages increased product loss by 56%. Looking at the pie chart on the bottom left, it was seen that 73% of days recorded in the historical data experienced stoppages. The rest of the days in the dataset experienced no stoppages. Finally, the pie chart in the bottom right corner displays the percentage of time with continuous product flow observed during the site visit. The team observed the product flow at the output end of the hopper for 9 minutes. During this time, it was noted that for 59% of the time, the system had no feed flowing. The rest of the time had continuous product flow.
The current state analysis findings allowed the team to develop 32 simio models to compare future state design alternatives, including the current state of the system, implementing a monitoring system, replacing the fastback with a regular conveyor, removing the hopper, and simultaneously removing the hopper and implementing a monitoring system. The average time in system per model type was analyzed, shown on the left. The current state model type produced the longest average time in system, which was about 5.8 minutes. There was a large jump in time in system when the hopper was removed, resulting in an average time in system of about 4.4 minutes. When the hopper was removed and a monitoring system was implemented, the average time in system decreased to 4.3 minutes. The operational stoppage reduction per simio model was also found, displayed in the table on the right. For all treat and line types, the monitoring system showed an average operational stoppage reduction of 7.05%. Replacing the fastback caused the operational stoppages to increase by 10.28%. Removing the hopper led to the greatest operational stoppage reduction with an average of 81.85%. As a reminder, the project objective was to reduce operational stoppages in the product conveyance system by 10%. Removing the hopper would meet this objective.
Lastly, let's discuss the return on investment, or ROI, for various future state alternatives. As a disclaimer, the ROI for replacing the fastback with a conveyor belt was not found because it led to an increase in operational stoppages shown in the future state design simio model analysis. It is important to note that these ROI savings, at the request of Nestlé Purina, only include savings from production costs and material waste and do not include possible ROI profits from increased throughput. The hopper removal had an ROI of $31,700 per year, or $95,100 over 3 years, with an implementation cost of $11,500. The monitoring system implementation had an ROI of $2,100 per year, or $6,300 over 3 years, with an implementation cost of $2,500. When combining the hopper removal and monitoring system, there was an ROI of $33,800 per year, or $101,400 over 3 years, with an implementation cost of $14,000. This project's impact can be seen in the company's sustainability goals and social outreach. The reduction of operational stoppages will result in an increase in throughput and thus a reduction in waste. The reduced waste includes time and material. In terms of the material waste, a reduction in treats falling on the floor results in less treats being transported away from the facility to be incinerated, therefore reducing transportation emissions. Additionally, the time that was previously focused on waste management is now an opportunity to donate more food, time, and money to social outreach initiatives like the Purple Leash Project. This concludes our presentation. Thank you for listening.